In this video, we are going to discuss about different types of federated learning. In our previous video, we have seen our previous lecture, we have seen that there are two different types of federated learning. One is cross-device federated learning and the other one is cross-silo federated learning. First of all, we are going to discuss cross-device federated learning. Machine learning model development workflow is presented here. In model development using machine learning, in machine learning, model development is done with the help of cloud data. Engineers send requests of some computation data, recommendations for training a model that I want to train on, how much data record I will be using, this optimizer and other details. The engineer sends request containing all these items. The job is submitted to one of the big cloud server, and the server will use any platform like TensorFlow as a pipeline to train the model. Now we can have multiple servers in a cloud. There can be many servers in the cloud. The job that is assigned will be performed in distributed fashion to completion. After training, we can store the result in a matrix to check whether or not model is up to the required quality of the or not. And if the model is up to the required quality, it is according to the mark, then the model is deployed to the set of the client devices. These are smartphones. These devices can be smartphones, laptops, or other devices. So if the model is validated, it is okay according to the matrix, then it will be transferred to client devices. Now the model is on the device. Like all the clients have the model. It might be a keyboard language model or any recommendation algorithm. Like it is pretty cool as people can have recommendation system for improved services on their own devices. Well, now we want to replicate the process. This whole training process, we want to replicate it. We don't want the engineer to worry about how the process is done. Actually, we are trying to do that. We do not have the data. And the thing is that we also have seen in previous video that the engineer has somehow access to data in the cloud. So the box inside the cloud, so the box inside the cloud, but in practice, in federated learning, we are never going to collect the data. We don't want the engineer to worry about how I'm going to make all these devices talk to each other, grab updated model for them, and it is very complicated process, and we want to hide it all under a hood and allow the engineer to continue to do what he is usually doing without noticing that under the hood all the infrastructure of machine learning has actually changed. This is where the federated learning is actually happening. Now we can see we do not have any packet data in the cloud. Training is directly being done between the client and the server. Let's see an example of federated learning, cross-device federated learning. In this example, we can see data is on the device and it is not on the cloud. For training purpose, we have to ensure certain steps that all the devices are properly charged so that power failure issues might not arise. Secondly, we need to ensure that participating devices are connected to unlimited internet or Wi-Fi or any other. We also need to ensure that device is idle, because if the device is not idle, then it will create a mess. If it is not idle, then in the backgrounds of training, the device will become slow and it will affect the training process. Let's see an example of cross-device federated learning. We can see data is on the device and it is not on the cloud. For training process, we ensure certain steps that first of all, devices are properly charged so that power failure issues might not arise. We also need to ensure that participating devices are connected to internet. And thirdly, we need to ensure that device is idle, because if it is not, then it will create a mess. If the device is not idle, then in the background of trainings, the device will become slow and affect the speed of training process. If all the criteria are met, then it can participate in training round. Now your phone is going to do is to ping the server to say that I am available and meet all the criteria and ready for computation. After a time, we will get a lot of devices. Let's see an example of cross-device federated learning. We can see that data is on the device and it is not on the cloud. For training process, we ensure that all the devices are properly charged so that power failure issues might not arise. Secondly, we ensure that participating devices are also connected to Wi-Fi. And thirdly, we need to identify that all the devices are idle. We have to ensure it in order to prevent the mess. If we do not ensure that if device is not idle, then in the background of trainings, the device will become slow and will affect the speed of training process. Now, if all the three criteria and others are met, then the device is ready to participate in the training. Now, your phone is going to do is to ping the server to say I am available and meet all the criteria and ready for computation. After a time, we will get a lot more devices as it is a large scale system. The server responses not now. Currently, the server do not need that device. And every once in a while, the server responses to number of devices that might be thousands of devices. Server responses them with yes, I need you to perform number of computations. So once the server responses in yes by ping, that is the point where the training process starts. Now what happens is that the engineer will send the initial model that is represented by green box in the cloud. This initial model can be a pre-trained model on publicly available dataset or may be trained on any dataset that has been acquired by the service provider in past, or it can be any randomly initialized model. So the engineer would send the model with its architecture and computation that is needed to be done. The device will use any platform like TensorFlow Lite or any other to compute on data and perform computation to update the model. Orange box is represented in this figure that shows the updated model. Now the client will send this updated model back to the server and server receives this updation. In fact, server is receiving multiple updates. Now the server is never going to store these updates. It uses these updates to update the initial model, and once the initial model is updated, it deletes these updates right away. So data is not transmitted from the device to the server, and once these updates are consumed, these are deleted. Hence, data privacy is protected. Now we have number of devices of clients that have participated in the training and sent their updates to the server. These all updated models are aggregated as shown by the submission box on the slide, and we get a combined model. When we get a combined model using these from these updates, we delete all the updates that have been received from the clients. Now this combined model is analyzed with matrices. If we feel that combined model is good quality, it is of good quality, then we stop the training process. But if not, then combined model is again sent to the devices as initial model for second round of training. We repeat the same over and over again until we get a model that satisfy the predefined metrics and of high quality and stop the training process. The engineer will now perform A/B testing on the model, and the model will be opted and will be used for further calculations. Typical order of magnitude of devices that are participating in the training are depends on complexity of computation and the size of model, whether the model is very big or model is very small. Hundred to thousands of users per round may participate in the training round, in every training round, and number of rounds may converge to thousands, and there may be 1 to 10 minute per training round. The time taken by every round can be from 1 minute to 10 minutes. So these or this order of magnitude depend on the complexity of the data set or the problem nature of the problem that we are trying to resolve. Next type of federated learning is called cross-silo federated learning. In this type of federated learning, we are handling institutional data. This data is not generated from devices, but the data generated by organizations, by data generated by multiple institutions like hospitals or universities or any other. Well, on this slide, we can see that multiple data collection centers are working to collect data. They are collecting their own data parameters and they are locally training their own data models. And after training their data model, they are transmitting their local data model to the central server for further processing using internet. In this slide, we can see 7 different models have been generated by different data collection centers. 7 data collection centers have collected their own data set and they have applied their own model. And after generating their data model, they have transmitted their data model to the central server. When server received the model, it applied meta classifier. It calculated meta classifier and applied federated averaging algorithm to develop global data model. Then global data model is responsible for making all the prediction and other calculations and computations. In this video, we have learned about two different types of federated learning. One was cross-silo federated learning and the other was cross-device federated learning. In cross-device federated learning, we have seen the operation of multiple devices in training the model, which has been updated by every model, every device, and then ultimately we obtain the combined model that will be used for further computation. In cross-silo federated learning, we have seen that different organizations and different data collection centers are collecting their own data. They are developing their own model on the data set and transmitting their models to the center server, where voting is done on the basis of by training multiple classifiers and applying averaging federated averaging algorithm. And then after training global model, then the computation will be performed accordingly. In the next lecture, we will see federated averaging algorithm.